Alright, now we're going to do the fourth digital electronics problem, and as always, we're going to start by translating the graph into a Boolean algebra expression. So we're going to look at the first gate, which is an AND gate, and fed into that gate is an A and a not B. So I'm going to write those in parentheses. The next gate is a NOR gate, and that's fed in by the product of A and not B, and a C. So that's what you get when you translate that graph. Now we want to use our De Morgan's laws and simplify this expression. So we know we can split this up into the product of two separate knots. So that's going to be the A not B not and the not C. Then we can split up the first part again into not A plus B, all multiplied by not C, and we can multiply that out, and that gives you not A not C plus B not C. Alright, now just rewriting the equation we just found, we have two options. Either do it out with a truth table, which is good practice and you can check your answer at the end of the video, or reason through it, which is what I'm going to do here. So if we reason through it, in order for the expression to be true, we need either one or the other to be true. So either not A not C is true, or B not C is true. Now we're going to find what values make this the case. So I'm going to say not A, not C is number 1. And in order for not A, not C to be true, we need not A to equal 1 and not C to equal 1. This of course means that A equals 0 and C equals 0. B is not involved in this expression, so it could be 1 or 0 and the first part would still be true. Now we're going to do the same thing with the second part. In order for B not C to be true, B has to be 1 and not C has to be 0. Or not C has to be 1, which means C is 0. So A is not involved, so it's a star. B is 1 and C is 0. Now we're going to write out all of the possibilities given from what we just found. So from the first part we got 0 star 0, and from the second part we got star 1 0. Alright, so all of the possibilities for this so that we can combine it into one answer, and we also have to check all of these in our equation. 0 1 0, 0 0 0, 1 1 0, and 0 1 0. We can see that we have two 0 1 0s right now, so we only want to write one of them. So the final answer to this question is 0 1 0, 0 0 0, and 1 1 0. And you can check this using a truth table and you should get the same exact things. But sometimes reasoning through it, if you're confident with your answer, can save you some time on the quiz.